All right, welcome back, everyone. So, Unit 4, Lesson 2 now. Example 2, find the value of all 6 trig ratios for 5 pi over 3. So let's, make our grid here. 5 pi over 3, where is that going to be? Well, we got 0 here, we got kind of like 50% here, 100% here, 150% here, then the 200, or 2. So 5 pi over 3, that's more than 1, because 3 over 3 is 1, obviously. 5 pi over 3, what is that? That's actually very close to 6 pi over 3, which is 2. So I'm going to guess it's going to be here somewhere. And remember, just convert it to degrees, and then you'll be easily be able to figure out which quadrant this is supposed to be in. So yeah, this quadrant here, and how far off are we in terms of completing a full circle here? Well, if 5 pi over 3 is here, you're supposed to do 2 minus 5 pi over 3. Or I guess you can leave the pi's out. But yeah. So 2 minus pi over 3, or here if you really want, 2 pi, I guess, minus 5 pi over 3. Remember this over 1, so that's going to be 6 pi over 3 minus 5 pi over 3, which is just pi over 3. The equivalent is 360 minus 330, right? Or no, did I make a mistake there? Apologies. How many degrees is 5 pi over 3? Let's just quickly do that. That's 60, 300. There you go. 60 degrees. There you go. So if you want to convert into degrees, 360 minus 360 degrees. So the angle inside is 60 degrees. Remember, we want to stick with the radian, so it's pi over 3. And the question is asking to find all 6 trig ratios for this angle here. Oh, well, okay, it doesn't matter. So you just got to do sine of 5 pi over 3 is equal to, have your CAS rule out. And this is the same thing as pi over 3. So we should get our pi over 3. So sine of pi over 3 is opposite, which is root 3 over 2. So this is going to be root 3 over 2. And the final answer is to see if it's positive or negative. And in this case, it is negative. And then, yeah, just like that, we're going to do this exact same thing with cos 5 pi over 3. Which is the same thing as cos pi over 3. Which is 1 over 2. And is positive, negative. Since it's quadrant 4, cosine is positive, so leave it as 1 over 2. And then tan 5 pi over 3 is equal to, let's go back, tan of pi over 3 is opposite, root 3 over 1, opposite over adjacent, so it's just root 3. And since it's quadrant 4, it is going to be negative root 3. Once you have the primary trig ratios, we can just write their reciprocals. So the reciprocal of sine is cosecant. So cosecant of 5 pi over 3. And remember, you're not taking the reciprocal of the angle. The angle doesn't change, just so you know. It's always the ratio. All right. So you're just flipping the answer here. So it's 2 or negative 2 over root 3. And secant 5 pi over 3 is just going to be 2 over 1, or just 2. And then cotangent of 5 pi over 3 is just going to be, remember this is a 1 here. So 1 over root 3, and then there's that negative sign. Okay, there's example 2. Let's move on to the final example for this lesson here. Oh, sorry, 1 second. Let me move this here. There we go. Okay. And we have a nice application question here. And let me actually get the diagram here. Okay. We got a nice little graph here. So let's read the question. Justin is flying a kite at the end of a 50-meter string. Okay, so we got a kite. It's 50 meters string. The sun is directly overhead, and the string makes an angle of pi over 6 with the ground. The wind speed increases and the kite flies higher until the string makes an angle of pi over 3 with the ground. Determine an exact expression for a 4D horizontal distance between the two positions of the kite along the ground. Okay, so I mean, it sounds confusing, but let's use some basics, stuff. Let's say we are, we got the ground here. We got a kite. Kite's flying in the sky, right? The first angle is pi over 6. So we know that's pi over 6. Now remember, if you aren't very comfortable with radians, you could write this in degrees. Pi over 6 would be 30 degrees. So this is 30 degrees. Okay. And we know that the string for the kite is 50 meters. So we know that this value here, this diagonal, is 50. We know the angle. And honestly, that's enough information that we can figure out the rest of this triangle, because it's a right angle triangle. But they change up the scenario. They're like, oh, the wind speed increased and the kite's higher up now. So it's higher up. Oh, let me just make that a solid line. Sorry. So it's higher up now. And in this new triangle, the angle is different. The angle is now pi over 3. I'm going to split this up. I'm going to have the two triangles side by side rather than overlapping, because it gets a little bit messy when it's overlapping, right? Okay. So this is our new kite with the higher position. Now the 50 meters doesn't change. The string doesn't change. The length of the string. And the angle, however, the change is pi over 3 now, which is the same thing as, what is that? 60 degrees. And we know this is a right angle triangle. And there you go. So here we have, I'm going to get rid of this triangle there. Here we have our two scenarios. Scenario 1, kite is, not that high. Scenario 2, kite is higher. And they're asking for the exact expression for the horizontal distance between the two positions. So when they were overlapping, we know that one kite is closer to the person flying than the other. So we're looking for this distance here. Horizontal distance between the two positions. So let's first get the horizontal distance for each individual kite. So we'll just write, x1 and I guess x2. So x1 is equal to what? If we're looking for this, we have an angle, we have the hypotenuse, and this is the adjacent side. And I'll give you a hint. Usually whenever you look for horizontal stuff, when it comes to triangles, most likely you're going to use cos, because cos kind of has to do with like the x-axis and whatnot. All right, so cos of pi over 6 is equal to adjacent, which is x over 1 over 50, hypotenuse, right? And x1 is just equal to 50 times cos pi over 6. And I haven't mentioned this earlier. I apologize. I should have mentioned this much earlier. When you are plugging in pi over 6 in your calculator and you're trying to evaluate cos of pi over 6, your calculator has 3 modes when it comes to these angles. It has a degree mode, it has a RAD mode, which is radians, and then it has another mode, which is GRAD. Now, in this course, we are dealing with radians, so you should have your calculator set to that mode. Obviously, if you're using degrees, then set it to degrees, but make sure whatever you're doing is set to this correct setting. So cos pi over 6, if we do that right now, what do we get? Well, actually, before we do that, I forgot one more thing. Remember it says exact expression? If you remember from grade 11, anytime in trigonometry a question is asking for exact values or exact expressions, that's basically a hint to use special triangles. So we're going to use our special triangles, which are here, and I forgot the angle already. Oh, pi over 6. So pi over 6 is this one here, and we're doing cos of pi over 6. So cos of pi over 6 is adjacent, which is root 3, over hypotenuse, which is root 3 over 2. So we know that cos of pi over 6 is just root 3 over 2. So this is going to be 50 times root 3 over 2. And that is my x1 value. And then obviously we can just do 50 divided by 2. And we're left with 25 root 3. So that's x1. Let's find x2. x2 is going to be what? The exact same thing, except the angle is now pi over 3. So it's cos pi over 3 is equal to x2 over 50. Because remember, we're still looking for the horizontal distance. It's just a different triangle, different angle. So the formula is pretty much the same. It's going to be 50 times cos pi over 3 equals x2. And cos pi over 3, exact value is, let's see, pi over 3. So this is pi over 3. Adjacent is 1. Hypotenuse is 2, so it's 1 over 2. So this is just 1 over 2. 50 times 1 over 2 is equal to x2. And then we have, obviously, half of 50 is 25. Now the question is, all right, which distance is bigger? Because we want to subtract the bigger number from the smaller number when it comes to horizontal distance. Doesn't necessarily matter because we're looking for magnitude. We can just do it. But yeah, we're just going to do x1 minus x2. x1 minus x2, which is 25. Sorry. 25 root 3 minus 25. You're just taking these values and subtracting them, right? And since we like to, simplify stuff, we're just going to do that. And that's the final answer. That's it. Delta x, or distance, or magnitude. Yeah. That is the horizontal distance.